Alright guys, so we're going to prove right here that given line EF is parallel to line BC, so EF parallel to BC here, and we're going to prove that AE over EB equals AE over EB equals AF over FC. Alright, so we're going to prove that those are proportional. So right here we start with our given in our first step here. So we got EF is parallel to BC, that's given. So by knowing that, we know that angle 1 and angle 2 and angle 3 and angle 4 are congruent. So 1 and 2 are congruent and 3 and 4 are congruent by corresponding angles. And the reason we know this is because if these two lines right here are parallel, alright, and they're cut by these transversals right here that run down, then 1 and 2 are corresponding angles, so they're on the top of the parallel lines, alright, and on the left side, and these two right here, same thing, got this transversal. That means that 3 and 4 are both on top and to the right side, so they're both congruent angles, alright. So that's how we know that they are corresponding. Okay, and then, so what can we know from that? So that tells me that triangles AEF, alright, so this triangle AEF here is similar to ABC, so the bigger triangle ABC. So those two are similar by angle postulate because they have two pairs of congruent angles. We just learned in the last step. Alright, and by knowing this, we know if they're congruent, then we can look at the sides of a larger and a smaller triangle here. So I know now that AB here over AE equals AC over AF. And I know that because corresponding sides are proportional. Alright, because those are our two triangles. Because if I had triangle ABBC here, it's the entire length of the whole triangle there. And we have the smaller triangle EAF is part of the length. So we know we have to use the entire length of AB in order to show the proportional relationship there, because it's still this side of AB, and EA. Alright, so that's our fourth step. Alright, so next we're going to have to use a postulate in order to continue. So look right here. We know that AE. Alright, so what we're going to do is we're going to add both sides by the denominator. So right here we're going to add AE to both sides here. So you can see here we added AE to both sides. Alright, and right here we added AF to both sides. Alright, so now we have segment addition postulate in order to do that. And you'll see why we're going to do that in just a moment. Why we're going to add AE and AF to both sides. Okay, continue. And we can do that. I mean, we know we can do that because if I got EB over AE and I add AE here, I keep my denominator, it's going to be AE plus EB. Alright, keep going. So now I can also write that like this. I can have AE over AE plus EB over AE equals AF over AF plus FC over AF. So I'm simplifying my fractions in this step right here. So you look back, that's the sixth step. Alright, I'm simplifying that same fraction because you can write it. And if you look at this property that AB over C, and the next step right here, that AB plus B, A plus B over C is the same thing as A over C plus B over C. And you notice we cancel out AF and AF, you get 1. AE and AN get 1. Alright? And then, so we're able to get 1 plus EB over AE equals 1 plus FC over AF. And right there, my next step is I'm going to subtract 1 from both sides, and I'm able to get rid of my 1's, and I get EB over AE and FC over AF. Subtract 1 from both sides. So now I get that because I subtracted 1 from both sides. And now to get back to my original, which is my original, I want to prove is AE over EB equals AF over FC. I just find the reciprocal, and I get AE over EB and AF over FC. So I took the reciprocal.